Dear students, welcome to s.mathguru classes. Today start the new topics, new interesting topics. This topics is that a Cauchy Euler homogeneous linear equation, or sometimes we call homogeneous linear equation. Uh, the equation x to the power n dn y dxn plus p1 x to the power n minus 1 dn minus 1 y dx n minus 1 p2 d x to the power n minus 2 dn minus 2 y dx n minus 2 dot pn minus 1 x dy dx pn y equal to x. This p1 p2 these are called constants and x is a function of x. This is called homogeneous linear differential equation. That means this power and this order is same. This power, this order is same. This is power n minus 2, here order also n minus 2. Both are same. So this type of equation is called homogeneous linear differential equation or Cauchy Euler homogeneous linear differential equation. We solved some problems, some videos given. All the problems, the coefficient of dy dx is 1. Highest power order, because coefficient is 1. But here we get coefficient is x to the power n. So this type of equation is called Cauchy Euler homogeneous linear equation. Now how to solve this problem? Let us put x equal to e to the power z. How to solve this? So if we taking log, then log x equal to z, we get this, and dz dx equal to dz dx means ddx of log x, this will be 1 by x, and also we write d dz equal to d square dz square equal to capital D square, d cube dz cube equal to capital D cube. We can write this. So we consider when we solve this problem, we putting x equal to e to the power z and taking log on both sides. Log e means 1, then z we get, and dz dx means 1 by x. Now we find dy dx. What is dy dx? Dy dx we can write dy dz dx. We can write this. And dy dx dz dx already we get 1 by x. So what we get? Dy dx equal to 1 by x dy dz, we get this, and this x multiplying on left hand side, x dy dx equal to dy dz. So or we can write dy dx equal to, this is dy, d dz means d dy, we can write x dy dx equal to dy, we can write. So we get this one. Now this is number, so we find second order derivative. Again d square y dx square, this can be written as d dx of dy dx, d dx of dy dx. Now we consider this is number 1, and this will be d dx of dy dx, we can write, and dy dx this value is 1 by x dy dz. In place of dy dx, we putting this value. Dy dx means 1 by x dy dz. So this is 1 by x dy dz. We get this. Now this implies d square y dx square equal to, this is product rule, UV formula, 1 by x d dx of dy dz. This is dy dz d dx of 1 by x. We get this. And this implies d square y dx square equal to 1 by x. This is d dz and dy dz. So actually here dx I have written dz. So we write here dz and dx. So this dz cancel ddx we write here. And this is dy dx. ddx of 1 by x means minus 1 by x square. We get this. So this implies d square y dx square equal to 1 by x. This is d square y dz square and dz dx means 1 by x. We know this, dz dx means 1 by x. Here we putting 1 by x minus 1 by x square dy dx. So we multiplying both side by, this is d dz, multiplying both side by x square, then x square d square y dx square. This is d square y dz square dy dz, or we can write this is d square minus d square y minus dy. So d square minus d into y, or we can write d common, d minus 1 y. So what we get? We get x square d square y dx square equal to this, d into d minus 1 into y. So what is the relation? If it is x dy dx, only x we write dy. If it is x square, then we get x square d square dx square, we get two factors. Similarly, others no need to prove. Similarly, we can write x cube. If we have x cube d cube y dx cube, then we get d minus 1 d minus 2 into y. In this way we can write this. And if we write x to the power n dny dx to the power n, then we get d minus 1 d minus 2 dot dot dot, we get d minus n plus 1 y. We get, this is the general term, x to the power n dny dxn d minus 1 d minus 2 dot 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 d n minus 1 d minus n plus 1 y. So we get this, and all the values we putting here and we substitute, we get an equation. So, and after putting this value x dy dx, we get putting this value x square d square y dx square, we putting this value. Just you have to remember, if it is x dy dx, we write dy. If it is x square, then we write d minus 1. If it is cube, then d minus 1 d minus 2. This three factors. And this is n, then we write n factors. This is the rule. By substitute this value here and we get an equation, and we solve this equation by the previous method. If right hand side exponential, we get another method. Logarithm algebraic, we get another method. Algebraic exponential mix up, we get another method. Already this type of problem done. Now this is our rule. Just you have to remember x dy dx means this, x square d square y dx means this, and x cube d cube dx cube y, this is this. When you have to solve this, no need to write putting x equal e to the power, directly we write this value. Now let us consider this problem. Solve x square d square y dx square twice x dy dx 4y x to the power 4. So here square, here 2. So this power 1, this order is 1. So obviously this is homogeneous linear differential equation. If it is homogeneous, then we solve this problem in this way. Solution: let us put x equal to e to the power z, and this implies log x equal to z, and dz dx equal to 1 by x, and d dz equal to capital D, d square dz square equal to capital D square. And just we given, we know this formula, no need to solve, directly we can write this x dy dx, we write dy x square d square y dx square, we write d minus 1 into y, we write this. Already solved this. How to find this already given. So just putting x dy dx means this, x square d square y dx square means this. So we putting this here. Now the given equation we have, for this we get, this is number 1 we consider. Now 1 implies x square d square y dx square means we write d minus 1 y, and this x dy dx means dy minus 4y, and this is x means e to the power z all to the power 4, and taking y common, this is d square minus d minus twice d minus 4 y equal to e to the power 4z, and this one d square minus 3d minus 4 y e to the power 4z. Now auxiliary equation equal to m square minus thrice m minus 4 equal to 0. This is m square minus 4m plus m minus 4 equal to 0. Then m common, m minus 4, 1 common, m minus 4 equal to 0. Now m minus 4 common, this implies m minus 4 common, we get m plus 1 equal to 0, m minus 4 equal to 0, m plus 1 equal to 0, m equal to 4, m equal to minus 1. We get this. Therefore, complementary function equal to c1 e to the power 4z, c2 e to the power minus 1z. We convert in terms of z. This particular integral is e to the power 4z by d square minus 3d minus 4. This. And this is exponential. We putting the coefficient of z 4, we putting in place of d. If we putting coefficient of 4, coefficient of z, this is 4, in denominator I calculate separately. This is 4 square minus 3 into 4 minus 4. So what we get, e to the power 4z by 0. We get 0 denominator. If you putting directly, the coefficient of z is 4, 4 putting in place of d by rules of particular integral. If we putting 4, then we get denominator 0. Denominator 0, then we multiplying numerator by z and differentiating this with respect to d. If we differentiate with respect to capital D, then this is 2d and this is 3, this is 0. And now putting the value of 4. Z e to the power 4z by 2 into 4 minus 3. This is 5z e to the power 4z. We get this is our particular integral. Therefore, general solution is y equal to CF plus PI. This implies CF means C1 e to the power 4z, C2 e to the power minus z, and Pi means z e to the power 4z by 5. This. So this can be written as C1 e to the power z whole to the power 4, C2 by e to the power z, z e to the power z whole to the power 4 by 5. That we express e to the power z. But e to the power z means x. Initially assume e to the power z means x. So this implies y equal to C1 x to the power 4 C2 by x, and z means log x into e to the power z means x to the power 4 by 5. We get this. So this implies y equal to C1 x to the power 4 C2 by x, and this is x to the power 4 log x by 5, and this is our final answer. Very easy solution, very interesting also. So dear students, these are very easy, very interesting. This is the first video about homogeneous linear differential equation. Next class we shall solve the remaining problems. These are very easy and very interesting. If you are getting easy and interest about this video, then please share the video to your other friends. These are important for engineering, all engineering courses. It may be civil engineering, mechanical, computer science, electrical and electronics. These are important. And BHC major also, major parts course both. These are important, this type of problem. So I hope you are all enjoying with me. If you are all enjoying, then please like this video. If you are new in my channel, please subscribe my channel and click the bell icon. Thank you.